Hello, hello, hello. Chapter 12. Get into stuff with circles. This says 12.1. We're first going to deal with tangent lines. So we're going to talk about what a tangent line is and the properties of it. First, you have to write this down. You have to know what a tangent line is. So make sure you write down this picture and label these two things. A tangent line is a line that only touches a circle at one point. And that point is called the point of tangency. So when there's a circle, the line just touches at one point, that's the point of tangency. So we have theorems that go along with a tangent line. One being, if we know that a line is tangent to a circle, then it's going to be perpendicular to the radius at that point. So OP is going to be my radius, and P is going to be my point of tangency. So whenever we have the radius and the point of tangency, it always is going to create a 90-degree angle. So my first problem says ML and MN are both tangent to a circle. This means circle O. What's the value of x? Well, OL right here, that's the radius, so that means this creates a 90-degree angle because it's at the point of tangency, and this creates a 90-degree angle. Since I have those two create a 90-degree angle, I can set up an equation. Because this is a quadrilateral, that means all angles equal 360 degrees. So I could have x plus 90 plus 90 plus 117, because those are my four angles, equal 360. So I have x plus 297 equals 360. Subtract 297. And I would get the answer 63 degrees. Now I want you to pause the video and attempt this problem by yourself. Again, it says ED is tangent. So that tells you something about that angle. And you should have gotten x is equal to 52 degrees because all the angles in a triangle add up to 180. So we also have the converse of this theorem, stating that if I know that two lines are perpendicular, then I can say that the line that touches it just at one spot is going to be tangent. So it's just basically flip-flopping it. Here's asking what is the radius. Now, I have a 90-degree angle. So whenever you have a triangle, a 90-degree angle, you can always think a squared plus b squared equals c squared. So first I'm going to write up that equation. I have to be very careful when writing this though. So this could be my a. So I have x squared plus 12 squared. This is going to be my hypotenuse. But it's this whole length right here. So this whole length would be x plus 8 squared. So now I'm getting into my algebra stuff because I have to FOIL this out. So I have my x squared plus 144 is going to be equal to x plus 8 times x plus 8. And FOIL's doing your first times second. So it's x times x first. That's x squared. And then I have x times 8, which is 8x. And then my insides, I have another 8x, 8 times x. And then my outside, or my last, is 64. So now if I simplify this, I have x squared plus 144 is equal to, I'm going to combine my like terms here, x squared plus 16x plus 64, and now I'm going to solve. First thing I'm going to do is subtract x squared from both sides. That's going to cancel both the x squareds out, which is nice. So 144 is equal to 16x plus 64. Subtract 64 from both sides, and I get 80 is equal to 16x. Divide by 16, and you get that x is going to be equal to 5. Or else you write r is equal to 5 because x is your radius. Because x is the distance from the center to the edge of the circle. Same type of problem, but I want you to try it by yourself. So go through the same process that we just did in the previous problem. You should have gotten 5.3 repeating, or 5 1/3 is equal to x. Next problem we want to see is ML tangent to circle N. So if this is going to be tangent, that means this has to be 90 degrees. So we have to check. We want to check, does a squared plus b squared equal c squared? Because if it doesn't, then it's not a 90 or a right triangle. So I want to check, does 7 squared plus 24 squared equal 25 squared? So I get 49 plus 576 is equal to 625, and I add those together, and I get 625 is equal to 625. So yes, MN or ML is going to be tangent to circle N. And my last two properties that I have for a circle, if we know if two lines are tangent to the same circle, and if they cross at a point, so they have to cross at the point, that means those two lines are always going to be congruent. So in this case, both of these lines are tangent and they both cross at points B. That means these two are congruent to each other. Also, you have to know what an inscribed circle is. Inscribed circle means that it's a circle inside of a shape and the edges of the shape touch at the circle. So meaning that it creates multiple different tangent lines. So in this, the triangle is circumscribed about the circle because the triangle is on the outside. So if I have an inscribed circle, I'm going to use those two previous properties to help me. That means here's a point of tangency and here's a point of tangency, and these two lines both cross at point A. That means these two lines will be congruent, so this line is also going to be 10. Here's a point of tangency. Here's a point of tangency and here's a point of tangency. And these two lines both cross at point C. So this little guy is going to be 8. And then I have a final point of tangency right here and here. And both these lines cross at point B. That means that this is going to be 15. So now I can find the perimeter. Perimeter is going to be the distance around the shape. So if I move around the shape, I have 10 plus 15. This length right here is going to give me 25. And then I have 8 plus 15. That's going to give me 23. And then I have 8 and 10, which will give me 18. So then I have to add up 18 plus 23 plus 25, and I'll get 66 centimeters. And that's all I got for you today. Make sure you took excellent notes, because this is your reference to help you with your homework. And have a great day.